Good morning, everyone. Um, we've started a new lecture series. We are discussing statistics 1 and 2. So, this is a continuation of the class. So, in our previous lesson, I explained to you the following words: discrete data, then continuous data. Please try and be making notes. Discrete data and then continuous data. Okay. So just to recap or remind you, I said discrete data is any data whose values are restricted to certain exact or distinct numbers. Yeah, so any data whose values are restricted to exact or distinct numbers is a discrete data. So we said that usually discrete data are not found by measuring. Yeah. And we give an example that ages of people is a discrete data. Okay. Then we also discussed about continuous data. So we said continuous data is any data whose value falls under the category of real numbers. Continuous data is any data whose value falls under the category of real numbers. I explained what real numbers are. And in summary, I said any number one can think of is a real number. Any number one can think of is a real number. So if you are saying that with continuous data, its values are under the category of real numbers, then indirectly we're trying to say that with continuous data, any number at all you can think of will be right under that. And throwing more light, we are trying to say that with continuous data, it can be anything. Yeah, it can be anything because the values can be decimal, it can be whole number, or anything. They are all under real numbers. Yeah, I use a word that any number we've been using in mathematics is a real number. So continuous data can be anything. Yeah, continuous data can be anything. Okay. And we said usually they are found by measuring. When you're trying to measure anything, you get a decimal. You get a decimal, and they are all under real numbers. You can get a whole number, they are all under real number. That's what continuous data is about. Now, today I want to define some other words like frequency. This word, sorry, my video is not on. I feel my hair isn't kept. The word frequency is used all around your course. You will see it in integrated science. You will see it in another, you see it in another, um, you will see it in another topic under mathematics. It's called probability. You also see it in some of your physics class and what have you. So generally when we talk about frequency, what does it mean? Frequency. Anyone to volunteer, please, let's be quick. Generally, when we talk about frequency, what does it mean? So I will try and restrict my definition to statistics, okay, but they are very similar. So when we talk about frequency, is the number of occurrences of individual items that fall under a particular class. So the number of occurrences of so the number of occurrence of individual item that falls under a particular class.
Yeah.
Madam, can they hear me or you are having a problem over there with connection? Okay. So it's the number of occurrence of individual item that falls under a particular class. Let's talk about, so let's look at this. I want us to be talking about
And what is your forms?
ages.
Sorry. Is it the only that place that you can see it?
No, I'm taking my test and
Okay.
which one? This one. This one should bring it. Where is the house?
No, you're not.
Can the class continue?
That's it.
Yeah. Let's talk about certain ages of people in a class. I'm sending one of you to a government school in Taifa. Okay, there is one government school called Taifa Community. Yeah, I want you to go to the A division and enter one of the classes. You enter class 5. Now, when you enter class 5 or primary 5, I want you to tell me then the ages of the students in that class. I'm sure you would pick up age 11, probably age 13. Do you think someone with age 13 will be in primary 5?
Yeah.
Okay. And what other possible ages can be in class 5? Or is this person is too young? I need you to cooperate with me. What about age 11? Is it a normal age, a regular age for someone in class 5?
Yes.
Okay, so now watch closely. So the ages here in statistics, we use the word class. So the class here doesn't just represent, let's say, class 5 or so. No, no, no. When we talk about class represent like the kind of findings you are undertaking. Okay. So in this case, we are looking at ages, isn't it? Yeah, so class here represent the ages here. Now, if you are talking about particular class, let's stick to age 11. So this become our particular class, right? If you're able to identify the number of people that are of 11 years, that are 11 years of age, like the number of people that are 11 years of age, let's say, and you find 3 people that are 11 years of age, 3 becomes the frequency. So frequency is the number of occurrence of an individual item under a particular class. So the number of occurrence of age 11, yeah, that becomes a frequency. Please, you understand? So if I want you to tell me the number of people that are 13 years, that becomes what? And you are able to find out that, oh, let's say 20 people are 13 years, 20 becomes what? The frequency. So in the same vein, if I ask you to enter into the learning room and check for me the number of girls and boys. Now, how many people are girls? That becomes what? The frequency. I want to know the frequency of girls in it. Even if I want you to tell me the number of girls and boys, that word finding the number of girls and boys becomes what? The frequency. Frequency is the number of like occurrence, an event or an item, okay, falls under a specific class. Please pay attention. We use this word under probability too, okay. But do you understand me? Do we understand what frequency means?
Yes, sir.
Okay, so I can move on. Yeah. So now I want us to look at this.
Mommy,
It's a way of,
mommy.
oh my days. Ajo, unmute yourself, please.
Sorry.
Yeah. Okay, yeah. I want us to look at this. This is a way of handling the data. Okay? It's a way of handling data, but I want you to know it's a frequency distribution. So I'm just introducing you to a couple of stuff, okay, before we start work. So frequency distribution, yeah, table. Okay. So so essentially the frequency distribution table is a table that arranges data by putting them into class and their respective frequencies. You know it. You know the frequency distribution table. Yeah, so I'm gonna show one to you. So I just told you that like where, oh, I just did one, guys. I just did one here. So this is a frequency distribution table. So it's a tabular arrangement of data. We use that to arrange data a lot. So it's a tabular arrangement of data, okay, by grouping them into class. So when I talk about classes, the event under discussion. So here, what are we finding? Ages. So by grouping them into class, or as in ages, and then their respective frequencies. Please, do we understand? Yeah, so there's a typical example of what? A frequency distribution table. Do you want to write the definition down or I can move on? You understand? Okay. Yeah. So, yeah, that is it. And talking about classes, yeah. So talking about classes can represent ages. Classes can represent anything you can think about. Anything you can think about. So it can even represent height. I can let you go there to investigate the height of people in a classroom. So it can stand for height. It can stand for anything. Anything you can think of, making findings for. Yeah. Okay. Now, let's continue. Now, the next thing I want us to have a look at is, please be writing something down. I don't want you to just sit there and not doing anything. Be writing something down. Oh, now you may feel I understand, but trust me, I'm going to load you with a lot, so write something down. The next thing I want us to talk about is the tally table. Yeah, I just want you to know that it's a different thing. Okay, it's not the same as a frequency distribution table. It's a part of it. All right. Uh-huh. Now, what is a tally table? So, the tally table. Okay, I'm gonna give you. Yeah. So the tally table, it's more like a distribution table. It's quite similar to the frequency distribution table, very similar, but this time around, it has a very important feature and it helps. Yeah, so I'm going to show that to you. So this is what happens. This is what happens. Um, let's picture this together. So I assign Anthony to go to that school, okay, to go and collect ages of students in a class. Pay attention. Yeah, go and collect ages of students in a class. So when Anthony entered the classroom, he just started with the first row. He questioned those on the first row to the end. Then he came to start with the second row, the third row, and the fourth row. I think the total number of rows that were in the classroom was 4 rows. Guys, pay attention. So when he started from the first row, hey girl, what's your age? He says, I'm 11. Okay, he moves to the person sitting by her, and then the person also said he's also 12. Okay, so he has a pen and a book, so he's just recording like that. Oh, he moves to the next, I'm 12 years. He moves to the next, I'm 12 years. He moves to the next, I'm 9 years. He moves to the next, I'm 10. Oh, he moves to the next, I'm 11. I'm 11. Okay, I'm 12. I'm 12. Like that. I'm 13. Okay, I'm 12. I'm 11. Okay, like that, like that, like that. So he has done this for like the whole persons in the classroom. And now you see, a data like this doesn't look organized. It's even hard. It's even hard to fathom. Okay. Especially when then the ages is too many. Imagine he was collecting ages of over 500 person, like in a whole school, ages of people in a whole school. Have you seen how it is? Yeah. Well, before he finishes, you see that the data is really scattered. So this is why we have frequency distribution table. This is why we have a tally table. Okay. But we are talking about tally table. Let me tell you the usefulness. So to make a tally table, first of all, have a class. So what are you discussing? Oh, you are looking at ages of people, right? So that become your class. Now, then in an ordinary frequency distribution table, the next one would have been the number of occurrence, right? But here, we'll use tally. You bring tally first. Then the next one that comes is frequency. Now, I want to state this here that what we are doing is not for exam, okay? It's like a realistic um description that when you use it will help you in your daily life as far as collection, handling, and distribution of data is concerned. Why am I saying that? So instead of this guy going to the classroom, taking his records like this, and at the end of the day, it appears anyhow, this guy can just have a table like this. Okay. Now, know the variation of ages in a class. Even per what I've recorded, you can see that we have 11 years. Then we have what? 12? No, I'm sorry. 9 years is there first, right? We have 9 years. What else again do you have? 9, 11, and 12. What else again?
9, 10.
So there is 10. So 9, 10, 11, and what?
12.
30.
And 13. So it is observed that these are the ages we have in a classroom. So, and you can do this by asking them, you can do this by like starting with a ring. Oh, do we have people that are 9 years here?
Yes.
If someone raises their hand, yeah, then you record. Do you have people that are 10 years of age? You record. Do you have people that are 11 years of age? So it gives you a fair idea of the ages you'll be working with. So you put it here. So you just start with the first table. What's your age? So if the person is 11, you just come to 11 years, then tally. We use some simple diagonal lines, tilted lines. Okay. So if someone is 11, you make a mark. You tilt it. It's not portrait. Okay. So yeah. You go on. Oh, another person is 12. So you make a mark there, right? Oh, there's another 12 again. So you make a mark. You see, another 12, you make a mark. Tilt it, please. And there is another 9, you make a mark. There is another 10, you make a mark. In exam, I will give you questions where I'm going to give you questions where they would like they went to collect the data, so they will present it this way to you. And people, it looks so messy that if you don't take care constructing a frequency, and it looks very messy. And the next questions they'll be asking you is to calculate for mean. They'll ask you to calculate for standard deviation, mean deviation, variance. And you cannot do these calculations without having a table, a tabular arrangement of this data. Trust me, the values they can be very they can be many. Yeah, what I've done, you can have it in like 5 to 10 horizons, and you know, exam comes with some tension already. So if you are just doing a frequency distribution table, like you just have ages and frequency, counting alone, like it will just keep you like that. So that's the relevance of tally table. So even me, when I'm assisting with any solution, I like to make a tally table instead. So I have my tally. So I just look at the possible ages that can be there. So me, I just start from the first age. And sorry, the first number I see. If it's 11, I just go and document. If it's 12, you see, so I've documented like 3 of the 12. The next one is 9. I come and continue. The next one is 10. I come and continue. The next one is 11. I come and continue. Another 11, then another 12. There is another 12 again. So in the tally table, when you make 4 marks, the 5th mark, you don't continue. You don't 1, 2, 3, 4, then you don't do this. No. If it's up to 5, use the 5th one to cross it. Then you start a new one again. That's what we do. Yeah, that's what we do in a tally table. You've done this in school, so. Then the next one is 13, you make a mark. Oh, there is 12 again, so you start again. There is 13, you make a mark. There is 12 again, you make a mark. There is 11, you make a mark. There is 10. Do we have this girl in the class? Evelyn? Yes or no? Guys, have I recorded the 10?
Yeah.
Okay, I recorded it. You saw it.
Yeah.
Okay, so have I recorded the 12 also?
Yeah.
You sure? Okay, it's fine. So there is another 11. Guys, what do I do with 11? Because it's 4 entries we've done so far.
6.
So I have to cross it. So when you do it like this, it's very difficult to like skip a point. So when you are done, you just count them. Oh, so just count the tilted lines you've made. So with 9, we have 2 of them. Then with 10, we also have 2 of them. With 11, we have 5 of them. 12, we have 7 of them. 13, we have 2 of them.
9, I have 1.
5.
9 is 1.
Which one do we have 1, please?
9.
And 13.
There is one more.
9 is 1. 13 is 1.
How come we made it 2?
So you made it quick.
But how can I make such an expensive mistake? Maybe because I'm talking. But avoid mistakes, okay? Now, in everything, you can add them. You can add the total frequency to see if it corresponds with the data. So if you count what was given in the question, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you add the frequencies, they must be 16. So 2 plus 1 is 3, 3 plus 5 is 8, 8 plus 7 is 15 plus 1, 16. Yeah. So yeah, that's so you see there's a tally table. So it's a simple like frequency table, but it has one particular column, and that column is called tally. And this is what we do on that tally. So yeah, that is it. Now it's important to know that going forward, you see a table. And you can tell that this is a frequency distribution table, but we will not write, you will not see us writing frequency. And you have to identify what is frequency in a table. Yeah. And the reason why I have to identify what frequency is in a table is that in the formulas I'll be giving you for mean deviation, standard deviation, and what have you, all includes like all have frequency in them. And if you do not know your frequency, then what are you going to use to calculate? If you mistake something for frequency, meaning you'll be using wrong stuff for calculation. So it's important to be able to identify frequency in the tables I'll be giving you going forward. Guys, please, what we are doing is very important. You see the way you guys have done so well with percentages. That's the same thing we're going to do for statistics. To begin, you must understand the terms. Every language we use, you have to understand it. If you understand it, as we delve deeper, you'll be able to understand the dynamics and you'll be able to communicate very well like a pro. If you skip the introductory phase and you are just good with the calculations, you can communicate well and we will still see you as a layperson. Okay. So yeah, it's important for you to be able to identify frequencies all by yourself. Okay. And I just told you that it just have to do with the number of occurrences an event or an item appear. So like I'm going to give you an example. Then you identify the frequency yourself. So number of failings. Is someone calling me?
No, sir.
Okay. The number of boys. Yeah, number of failings, you can just reimagine the possible cases. We will use this word. Number of failings, the number of points. Yeah, let's see. So you can imagine like a possible scenario would have this number of failings. And I can help you out. Let's say, I don't know if you've been to the cinema before. If no, what other realistic example? But well, I can explain. Yeah, I don't know if you have been to like a mini cinema before. Okay, let's say they want to premiere a movie. Kwadwo Nkansah Lewin um authored a movie and it's being premiered today. When I talk of movie premiering, I believe we understand this.
Yes, sir.
Guys, please hold on. Please hold on, guys. Okay. What's the name? Okay, all right. Yeah, yeah. So yeah, back at the scenario I was trying to put across. So when you go to the cinema, it's just simple rooms, okay? Yeah, it's a simple rooms like your classroom. Then they have a projector hanging up in the air and then a white frame, but the room is very dark, so they just projected the movie. So we are about premiering a movie. And we can imagine a setting where we have like two, three rooms for like two, three rooms, all serving one purpose. It's all part of the cinema. Okay. So when here is filled up, we have another room with the same setup, right? So they are about premiering a movie and they want to show everything at once. Yeah, they want to show everything at once. Or this investigative journalist, Anas Arimere Anas, when he carry out his investigation yeah, and put the videos together, he often premiere that, right? And a lot of people want to go and watch. So, yeah, so we can imagine his um his should I say a video being premiered and at the cinema, and a lot of people have gone there. Now in that particular set in that cinema, the movie was premiered. There were about 5 rooms, okay. There were about 5 rooms. And we want to just check the attendance. Okay, so we want to look at the number of fillings for a room. Please, okay. Number of fillings for these 5 rooms, but specifically we're targeting um yeah, specifically we're looking at the number of boys, okay, per filling. So I mean this is a typical scenario we can have. So um please hold on, I'm coming. I'm just being distracted with a message. All right, yeah. Uh-huh. Yeah, so yeah, so we have number of fillings. Uh no, 0 is unrealistic. Let me change it to a number. Hmm, Let's see. No, some of these numbers are so unrealistic for me. I'm coming. I'm coming. I want to change them. Let's say we have 20 fillings. Okay. We have 45 perhaps. I just want realistic numbers for you. Yeah, we have 45. We have 30. We have 29. Then we have, yeah. So over here, yeah. So the number of fillings, we have 20 fillings for the first room. The first numbers were unrealistic. But in context, in the kind of scenario I'm trying to put across, the numbers there that was here previously, yeah, it's unrealistic. So yeah, we can use this one. So if you take a particular room where we have 20 fillings, number of boys we have 9. You take one particular room, number of fillings we have 45, and number of boys over there we have 15. Okay. One other room, number of fillings is 30, and the number of boys here. So which one here will be your frequency? Which one here will be your frequency? Because it's not
That is
written here class, it's not written here frequency, and you have to identify the frequency here. So what will be your frequency here?
the number of boys.
Yeah, the number of boys. Do you understand that? The number of boys. Because if you study this very well, we looking at the number of times, the number of boys per a room filling. Okay. And that's the frequency. Frequency is the number of occurrence of an item for a particular class. Do you understand? So number of boys here becomes the frequency. And like going forward, we will not, if you're lucky, we will state frequency, but most of the times we will not state it and you have to do it yourself. Yeah, so that is it. So we've spoken about frequency distribution table. Now it's a tabular arrangement of data. Okay, with class and your corresponding frequency. And we looked at tally table. It's just a part of frequency distribution table. Now, guys, today, now, can I move on? If you have any question, ask. Can I move on? Now, going forward, we are getting deeper. What I'm doing is very important. If someone is asking a question that I've not heard, you might have to speak out loud. Now, we have two types of frequency distribution table we'll be talking about here. We have grouped and ungrouped frequency distribution table. We have grouped and ungrouped frequency distribution. Okay. And it's not rocket science. It's how you understand it. Yeah. It's how you understand it. I will start with a group frequency distribution so that you understand ungrouped very well that we already have an example of ungrouped on the board. So yeah, I'll start with group frequency distribution table. Yeah. So with group frequency distribution table, instead of, you see, sometimes the ages can be many. Okay. Sometimes the ages involved can be many. You imagine like this thing here, 11. Well, 11 to 11 here, right? Imagine you have about like you have about so you have another one on this row, another one on this row, another one on this row. And then like you have a variety of numbers. It can be many, right? So imagine if you are asking to construct a frequency distribution table and at ages, it's like that particular class. You have someone who is 10 years. You have someone who is 11. You have someone who is 12. You have someone who is 13, 14, 15, 16, 17, 18, 19, 20. In the government school, now, I think now things are changing, but those days in the government school, people can be many. I remember when I was in school, in SHS, where like, I think we're almost like 100 in total. How about you? What's the total number of people in your class back then? Let's talk about SS. Come again. You were 80.
57.
Wow, you see?
21.
You were 21.
Yes.
I think those that went through double tracking lately, they find a way to reduce your numbers. Ajua, did you attend a private school? Was it a private senior high?
No, Achimota School.
Yeah, so double tracking, they've reduced your numbers now. Our time were like about 100. The person who said 80, what year did you graduate, like senior high?
80.
Come again.
57.
Come again. And you said
57.
57, yeah. What year did you graduate?
Last year.
Oh, 57? Even tracking. Was it a private or government school?
That was a government school.
Government school. Wow. 57 is still a lot. Though.
I think it depends on like the number of classes they have.
Okay. You have a point. Yeah, you have a point. So yeah, you picture like a class. They are they are 50 in a classroom, and you are going to pick ages, and someone is 18, someone is 19, someone is 20. Like you have someone who is 21, 22, 23, 24. So you have like about 30 varieties of ages. Come on, that's a lot. If you still not see how weighty this can be, you have 30 varieties of ages. That means over here at ages alone, you are come to write 30 varieties of ages. So like she had like someone who is 11, 12, 13, 14, 15. What I've written is like 1, 2, 3, 4, 5. And I'm even out of space. And like you have 30 different ages. You see, it can be a lot, right? So there is something that mathematicians have been employing. They try to put them in a range. So the range can be even or uneven. So they can have 11 to 15. Okay, have you seen it? 11 to 15. Then 16 to here. I want us to concentrate on even interval. 11 to 15, what is the gap in it?
5 and 7.
It's 5, right? So the next one will be 16 to 20, right? 21 to 25. Please, are you with me?
5.
Let's say the ages that you collected, there was 11, like you had 30 varieties of ages, but the highest, the eldest person was somewhere around 30, right? So we can have another range.
From 11.
It's
4.
What's your business now? I'm forming my own question. What's your business?
It's 4.
But do you know what? Okay, 11, okay, if we're 11 years, I admit that you can see they are too young. But it's not surprising. 11 years is very young.
Dad, did I have a question?
Yeah, ask.
Yeah, please, what's the interval between 11 and 15?
It's 4. It's 4. The interval between us is 4.
Say why 4?
So the 11 is
11 to 15, the gap in between is not 4. Or you are subtracting. The gap in between it is 4. How many steps before you move to 15? That's what we're talking about. It's 4.
35.
Yeah. You can do it this way. Subtract the like the upper from the, you will use those technical words soon. Like do 15 minus 11. It will show you. The interval is 4. Do 20 minus 16. It will give you that. My dear, don't think too much, okay? Just like 11, be counting your fingers. 12, 13, 14, 15. So the gap is what? 4. Be counting your finger. Just don't think too much. So yeah, let's say after recording the numbers there, the highest there is 30. No. The highest there is like 27. 27, okay. The meaning if we leave the interval at 25, we will not have a place to document 27. So we have to continue 26 to 30. Please, we are looking at cases where the interval is even. Listen. So this is what we call group okay frequency distribution. This is what we call grouped frequency distribution. And it's obvious, right? You've put the ages in a range. So it makes your entries shorter. Do you guys understand me? Hello.
Yes, sir.
Are you sure you understand me?
Yes.
So you understand when I say it makes your entries like shorter. Instead of like having to write 11 all the way to 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way to 30. You see, this one is shorter, right? So when you come to the frequency aspect, it's not anything. When you come to the frequency aspect, what this means is, and you can even have tally here too. You can have tally, don't forget that. So what this means is that if you see 11, someone of 11 years is in a range, so you count it. If you see someone who is 12, you count it. If you see someone who is 13, you count it. If you see someone who is 14, if you see someone who is 15, you count it, okay? You count it. So if you are counting them, you end up getting frequency. So let's say you have 2, you have 9, you have 4, you have 25. Please, are you with me? 25 is 2 gross. Let's say 7. So yeah, this is grouped. I've grouped them. Does it make sense? Now, guys, I want you to know that group, you see here, you were trying to establish a same interval for all of them, right? The interval is 4, right? I just want you to know that it's not all cases the interval is the same. Core math, you are mostly going to meet questions, the intervals are the same. By elective math, just remember that you can have a question where the intervals are not the same. What I mean is that here can be 11 to 15, but the next one can be 16 to 24. Then you come back again like it's unequal. Please, do you understand me? Yes. Yes.
Sir,
Oh, I can hear you. Please talk to
please, the
me.
interval between 16 and 20, I think
It's from 8.
Sir, the frequency
Uh-huh.
for 20 to 16 is 10.
16 to 20.
It's 10.
20 to 16, 16 to 21. Why are you coming back? Why are you reversing? Do you walk backwards or you work forward? Please, what's your problem? If you want to know an interval, just take just take the numbers here and then subtract what this one's from it. So that's all. That's how you get to know the interval.
4. It's 4. It's 4. 1 is 7.
Just take 25. Then subtract 1 from it. 30 minus 20. I'll use the word soon. Upper class limit minus lower class limit. 50 minus 11. 20 minus 16. 25 minus 20. 30 minus 26. Okay, that's how you get to find interval. Please, you understand?
Yes, sir.
There's a difference between class width. We'll come to that. Yeah, we are doing it bit by bit. Okay, we'll come to that. There's a difference between width and then interval. Interval, I've explained. You must understand. And I said something very important. He asked the question. Some people may have forgotten that. Please, what did I say? I said something very important about the interval.
They are equal.
Yeah, they are equal. And I said, I also added something important. I said you will meet another case.
In elective math.
Yeah. Yeah. You still haven't said it to me.
Oh, in elective math, it's not all the time that they will be equal.
They will be equal. The range can be anyhow, like different interval in each of the range. My people, do you understand what I'm trying to say?
Yes, sir.
Yeah. So, yeah, that is it. And then when we talk about ungrouped is what you see here. Okay, this one is what you see. This is what we term as ungrouped. You see, they are not grouped, right? They are not in any range. So I believe you understand the difference between grouped. You will be able to distinguish between a group and non-group frequency distribution, right? Okay. Now, I just want you to know that. Now, let me continue. Now, can I move on? So, I use certain expressions and I just want to define them. Yeah. Now, I use the word class interval. So, when I talk of class interval, it's a range, okay? Class. I use the word class interval. I just don't want to document it for you. So when we talk of class interval, we are talking about what? The range of possible values, right? So over here, so 11 to 15, that's a class interval. 16 to 20. What other class interval do you see? Hello. What other class interval do you see?
6 to 30.
Hmm?
6 to 30.
Yeah. Yeah. Okay. Now, when you take these intervals, the number you see are called class limits. Are we learning? I'm teaching a lot of things. That's why I advise that you write, I'm going to use this going forward. So you'll be wondering, what is he talking about? So know it today. So when you take a typical class interval, the number you see are called limits or class limits. Okay, yeah, because ages is a class. Like it's in statistics terms, we call that class. Okay, so yeah, the numbers you see are called what? Class limit. Not any number. We got two on the board. You see 2, 9. They are also numbers. No, I'm talking about the numbers you find under an interval. So when you take a typical interval, the numbers you see are called class limits, okay? They are called class limits. Now in that class limits, so 11 and 15 are called class limits. Now in that class limit, the lower number, the number that seems to be smaller is called lower. So per any interval, one is lower and one is bigger. So the smallest number is called the lower class limit, and the biggest number is called the upper class what? Limit. So an example is 11 to 15. So the least number there is 11, right? So 11 is the lower class limit, and 15 is the upper class limit. So when you take 26 to 30, Hannah, which one is the lower class limit and which one is the upper class limit?
Then 26 is the lowest.
Lower class limit. And 30 is what upper class limit. So now back at the interval, we're trying to find the interval between like the gap, the difference between the interval, and I said to know the difference between the interval, just take the so I was just explaining it anyhow. Now I'll use a term. So you just subtract, find the difference between the upper and lower class limit. Simple. So you take the upper class limit, which is 15, then you subtract the lower class limit from it, and you get a you get the interval, the range. Okay. So that is it. Please, any question? Can we move on? I'm saying that, like, we're trying to learn. You see, we just wanted to know the gap in between them, the intervals, if it is even, if it is equal, right? And we're arguing. And I was teaching you how to go about that. subtract this from that, but I was lacking terms, so I just explained it anyhow, even though you understood it. So now that we know the right terms to use, I just want to say that if you want to know the gap in between an interval, just take the upper class limit. So in this case, 20. Then subtract the lower class limit from it. So that will be 20 minus 16, and you get 4. So you see that it's 4, 4, 4, 4 throughout, and it's even. And guys, going forward, when I give you a question, like that's all to ask you to calculate for frequency, calculate for standard deviation, calculate for mean and stuff. Please, it's important that you check that data to see if the gap in between them is equal. I'm training you to be good mathematicians, statisticians. So when I give you a question and the question is grouped, try and check throughout the data if the interval between all of them is the same. Because if it's different, you can't be solving anyhow like what you know. There is a different thing we have to do. So try and ensure that they are the same. But for core mathematics, almost all the questions you'll be meeting will be what? The same. Now, I also want you to know that are we learning? Are we picking some information? Are we learning?
Yes, sir.
Yeah. Now, I also want you to know that I like talking a lot because I've seen like diversity of questions. So I like hitting all angles. So when you see them, they are like I caught you there. Yeah. So yeah, I also want you to know that. So in exam, they can give you scattered data. They'll just go and pick up a data and they come and write to you, like one I'm come to give you right now. Okay, they'll just scatter the data for you. So yeah, so you have 31, 40, 20, 35, like scattered values. Then they tell you that, construct a group frequency distribution table for that data. Okay, with equal class interval. Okay, so listen, they said with equal, maybe I should give you that as an assignment. It's okay. Let's do this together. So the number, write this. The number of runs scored by 36 batsmen in I presume it's a cricket. Is it cricket? Yeah, in a cricket competition. In a cricket competition is in a cricket competition is as follows. The number of runs scored, scored, like scoring.
Okay.
So you have 31, 40, 20, 35, 21, 12, 11, 39, 16, 0, 28, 49. We have 29, 32, 17, 2, 12, 24. We have 14, 1, 10, 23, 19, 13. We have 26, 30, 10, 21, 18, 0. We have 15, 11, 29, 8, 12, then 1. Now the question follows. Tally these data in a group frequency table. Use equal class intervals. Zero to 9, 10 to 19. Yeah. So try and do the set it up. But the reason you finish right and then I go. So the reason why I brought this question up is so this actually these data frequency table. Use equal class interval 0. So they want you to present a group frequency distribution table for this. Remember a tally table, okay? Now they said use equal class interval and they started 0 to 9, 10 to 19. Now you have to continue. So you have to follow the pattern. Oh, 0 to 9, they move to 10. All right. Yeah, so 10 to 19. So from this, you should be smart to know that the next one will be 22. I think the gap is 9, so 20 to 29, right? 30 to 39. Like you continue like that. And don't write too much because you also have to consider the highest number right here. Okay? The highest number right in the data. So just take note of that. Remember, they say use equal class interval and you are constructing it. They said tally these data, so be wise. Okay. Thank you. Any question, guys? So do it.
Okay.
Mhm. So just construct a table, have good titles for your class. Mhm.
Done.
You are done, eh?
Yes.
Okay. So let's wait briefly and let's get to them too so we can compare the values.
Okay.
And this thing you guys, you see, like quite simple. I can have a lot, like after you constructing the table, I can have a lot of questions for you. I can ask you to investigate for the mean from that. From this, I can ask you to look for the modal class. From the same table you're gonna draw. From that same table, I can ask you to tell me the mean deviation. That would make you create extra, columns. Yeah. I can ask you to calculate for the standard deviation. I can ask you to calculate for variance. I can even make you use that table to, construct a histogram. Yeah, a histogram or a cumulative frequency curve. Like, it's just interesting, and we'll get there. Can ask you to look for the percentiles, the quartiles, and the deciles from that same table. Yeah. What's this? Sorry. Yeah, so I said a whole lot of things and it was never recorded. Yeah, so yeah, we're talking about class boundaries. Yeah, we're talking about class boundaries. Yep. But let's write the frequencies first. Yeah, so here is 6. We have 14, 9, 5, 2. So again, I said that when you take a typical class, each class has a boundary. And talking about boundary means, it's a range here. You can go away from 29, but you can't go too much because you end up entering into a different class. Boundary separates classes. So each class have the least value it can assume, the highest value it can assume, just so it doesn't eat into a different class. That's what we term as boundaries. Yeah, class boundaries. Yeah, so I was given an example that when you take this very class like this, the least class, the least value it can have is 19.5, and that's what I'm coming to show you. Yeah, and the greatest number it can have is 29.5. Yeah, so it can be 29, 29.1, 29.2 whatsoever, but the highest is 29.5. If you extend further, trust me, you are coming into a different class. And the least value you can have is this 19.5. If you descend lower, you enter into this class. Remember, this class ends at 19, right? It also has a boundary, and we are coming to talk about that. So, yeah. So, yeah, let's look at, this, under this category, I'm going to teach you how to calculate for class boundaries. Now, I want you guys to open your ears. So, first of all, to calculate for class boundary, identify two classes. Okay, two class interval. So you can choose this two or any other two you want. Just identify any two class pay attention. Yeah. You should some students have it in their head that add and subtract 0.5, so they are carried away. Now the questions that are given to you are different. Yeah. You have to investigate what you are adding and subtracting, so pay attention. Yeah, so identify two class interval. Now find the difference between the upper class, find the difference between the upper class limit of the very first class and the lower class limit of the next class. So identify two class interval. You find the difference between the upper class limit of the first class and the lower class limit of the next class. In mathematics, if you say find the difference, it means conduct subtraction with sense. Again, in mathematics, if we use the word, there's a way to explain that, subtract this from that. I would mean, we have different ways of presenting it. But in the moment I say I use the word difference, I mean like subtract one from the other with sense. When I say with sense, you subtract something small from the something big. Do you understand that? When we use the difference, we leave you to the options. But there is another way. It will be like subtract 39 from 49. That one I've shown you how to go about it. But if I say difference, you do that with sense. So yeah, again, we are looking at how to find the class boundary. So first of all, this is Jota work. You find the difference between the upper class limits of the first class and the, so you see, you can see that it's between 39 and 40 here. So we are coming to find the difference. This is where you apply sense. 39 and 40. 40 is big. So you write 40 first, then you subtract the 39 from it. That's what I'm talking about. And it's going to be like that. When you subtract, you're getting one right. The answer you get, divide by 2. Divide the answer by 2. All cases. After finding the difference, you divide the answer by 2. You are getting half. What's the decimal of half? It's 0.5, right? 0.5. Now, this is what you're going to do. So you take your calculator. And then when you take this class, you take the lower class limit, 0, then you subtract 0.5 from it. Please, are you following?
Yes, sir.
0, you subtract 0.5 from it. What do you get? Negative 0.5. And mind you, class boundaries are ranges. Negative 0.5 to, yeah. Then you take the next class limit, which is what, 9. Add that 0.5 you add to it. So 9, add 0.5 to it, you get 9.5. So this is a class boundary range. Let's move on. The next one, 10. When you take 10, you subtract that value has 0.5. Subtract 0.5 from 10. What do you get? Why? Your calculators have started suddenly is dysfunctional. Huh?
9.5.
9.5. Then, yeah, take the other one, which is 19. So usually you subtract from the lower class element, you add to the upper class one. So 19, then you add 0.5 to it. What are you getting? 19.5. See, I'm going to pause. It feels your silence speaks volume. It appears you may have a question. So ask your question and let me continue. Before I continue, if you're okay to let me know. So it starts by knowing what to add and subtract. Once you know what to add and subtract, if you take a class, the lower class limit, which is 0, what comes first? You subtract that number from it. You add that number to the upper class limit. Come to the next, subtract, add, like that. Okay. But now you have to start by finding what you are to subtract and add. And what you are to subtract and add can be found by identifying like a group, and they must be in chronological order. So you have to take 2 immediate class intervals. Then you find the difference between the upper and lower class. And then whatever you get, you divide by 2. And that gives you what you are adding and subtracting. Please let me know if I can continue. If you have any questions, to let me know. I barely hear you guys. So everyone is fine.
Yes.
Prince, Media, Occupations, Frankana, Grace, Anthony. Okay. So so if you come here 20, you subtract 0.5, right? That becomes what? 20.5, right? Then to 29, right? Yeah. So this one, to what do you get? 30, subtract 0.5 from that. You get what? 39. Just add 0.5 to it. So this one, you get what? 39. This is Yeah, that's all. Okay, so that's it. So I just want you to know how to find class boundaries. So I'm coming to give you like one. I just want you to know it's not the time 0.5, 0.5, you know. That's why I have to find or investigate what you are adding and subtracting. So you create a class boundary for this before like we can continue the discussion. So I want you to create a column for class boundaries for this. So I have max, then we have frequency. $982,000 $1082 yeah. Then 11802 1002. Because I'll be uploading the lesson, I think after this we can continue further. Yeah, let's see. We'll just have a conversation instead because to make the video long. So the frequency is 10 here. 15. Oh, sorry. Oh, 15 and 24. Yeah, so just find the class values. Again, don't start by adding and subtracting 0.5 when you don't know what you are up to. So investigate what you are going to add and subtract first before creating this. Yeah. Okay, so we are just picking results from the student. So 940 to 1040. The next
1040 to 1140.
1140. Class, are you getting the same thing?
Yeah.
Oh, that's good. Guys are naturally brilliant. Yeah, the next one, please.
11402 to 1240.
Okay, so one, two.
Yeah.
You all had that.
Yes.
Always look for, find your class boundaries like this. This thing, no one will tell me. Okay, now there's the last thing we're talking about. I'm not even initiating anything further. So the last thing I want to say is, so you see, these are class boundaries, right? In class boundaries, you know, we have the list number, and we have a greater number, right? So like the list number, instead of calling it lower class limit, no, say lower class boundary, okay? Yeah, so lower class boundary. Then the greatest will be what? Upper, yeah, upper class boundary. Please, you understand?
Yes.
Yeah, so when I meet you again, I'll just talk about class size, or we call that class width. That is
Yes.
very important. So that's where your argument was coming from. I'll clear the air. Yeah, class width. We'll need it. We'll need it because I've seen a question, I've seen a question that will ask you to look for mode from a histogram. And sometimes you have to read, most times you have to read it, but students find a problem with reading. So I'll be showing them a formula that will give them the value as though they read. And that formula includes a C, a letter C. That C stands for class width. When you see small c in statistics, it means class size or class width. And you must know how to find class width. Other than that, you can apply that formula in your Jota. So you see, everything like will be up to has a purpose. Then I'll teach you class midpoint. Class midpoint too is important. Yeah, because see, the group is easy to work with on group frequency distribution table. When I say on group, that one that is 1, 2, 3. It's easy to work with them. But the moment they are grouped like this, to find the mean is challenging. You have to create a column to like shrink this to like a value. So you have to find a midpoint. So we'll learn how to find class midpoint. And now, so that will be it about the terminologies and anything you need to know on the statistics. So that'll be it. I'll teach you class width and then class midpoint. So then now I'll teach you how we graphically represent data. You go and collect data. We can represent them graphically and they appear so well. And I'll be teaching you the variety of ways we graphically represent data. And yeah, I think that will be it's broad, yeah. That'll be the end of statistics 1, and I can now usher you into statistics 2. Mathematics is not hard at all. Yeah, so yeah, this will bring us to the end of this recording.